Looking for the best GPU for AI video generation or 3D? In today's presentation, we will compare the NVIDIA Consumer RTX 5090, Workstation, RTX Pro 6000, and Data Center B200.
If you've spent any time looking into AI video generation, you already know the results are just absolutely mind-blowing. But the second you peek behind the curtain at the hardware it actually takes to generate those videos, yeah, you're usually met with some truly terrifying numbers. So today we're going to demystify those hardware costs. We'll look at 3 completely different tiers of graphics cards, break down what actually matters for AI video, and honestly, just completely rethink how you approach outfitting your studio. Let's get to it. $13,250. Wow. Just take a second and let that number sink in. That right there is the enterprise price tag for NVIDIA's flagship workstation card, the RTX Pro 6000 Blackwell. I mean, for most solo creators or small studios, dropping over 13 grand on a single graphics card, that's a massive, potentially prohibitive financial stake. And honestly, it immediately begs one very specific question. If a workstation GPU costs nearly 7 times more than a high-end consumer card, is it actually 7 times faster at generating AI video? Well, the short answer? No, not even close. And that is exactly why we need to completely reframe how we look at this whole hardware conflict. We've got to stop chasing pure speed and start diagnosing our actual bottlenecks.
Section 1. The 3 contenders. Classes of GPUs. To really grasp this, we're going to look at these 3 drastically different hardware tiers using a classic vehicle analogy. First up, we've got the RTX 5090. Think of this one as the high-end sports car. It is literally the absolute pinnacle of consumer-class hardware, starting at about $1,999. Under the hood, it boasts 32 gigabytes of lightning-fast GDDR7 VRAM. So just like a sports car, it's built for fast, general-purpose daily driving. It handles 3D rendering, heavy video editing, high-end gaming, and local AI generation brilliantly. It's incredibly fast, it's relatively affordable when you compare it to enterprise gear, and it's perfectly balanced for most desktop workloads. Next up, meet the RTX Pro 6000 Blackwell. Now this is not a sports car, this is the heavy-duty pickup truck. It's professional workstation class, carrying that massive $13,250 price tag we talked about earlier. But notice the specific spec here, 96 gigabytes of ECC GDDR7 VRAM. Guys, that is 3 times the capacity of our sports car. This card isn't engineered to win a proportional speed race. Nope, it's built to haul massive memory payloads without crashing.
And finally, we have the NVIDIA B200. If the Pro 6000 is a pickup truck, well, the B200 is a freight train. This is a full-on data center accelerator. You don't just, walk into Best Buy and pick one of these up. They're procured through server and infrastructure vendors. It features a staggering 180 gigabytes of HBM3E VRAM and up to 8 terabytes per second of memory bandwidth. It's built for massive enterprise scale and sustained throughput. So yeah, it's totally unbeatable on the right tracks, but completely impractical and unpurchasable for your home driveway.
Moving to Section 2, what AI video needs. Hardware priorities. So we've got our sports car, our pickup, and our freight train. But before we can pick the right one for you, we need to shift gears for a second and look under the hood at what AI video models specifically demand from this hardware.
The absolutely crucial point here is understanding 2 critical terms, tensor cores and VRAM. See, AI video models don't work like traditional 3D graphics. They rely on neural networks crunching massive amounts of math. Tensor cores are the specialized hardware that accelerates this low-precision matrix multiplication. Simply put, tensor compute drives the speed of your generation. VRAM, on the other hand, is your local memory capacity. It dictates what actually fits on the card, your model weights, your upscalers, your latent tensors. So if tensor cores are how fast the car goes, VRAM is the size of the car's trunk. And if that trunk isn't big enough for your payload, the workflow just crashes, or it gets incredibly slow as it's forced to offload to your system RAM.
And honestly, this perfectly illustrates a massive myth that we just need to bust right now. The idea that a great gaming card is automatically the best AI card. High-end gaming relies really heavily on ray tracing cores, which calculate how light bounces around a 3D environment. But AI video models, like diffusion and transformers, they normally don't construct 3D scenes to cast geometric rays through. They literally ignore ray tracing hardware. Instead, they are absolutely starved for VRAM capacity and memory bandwidth. So paying top dollar for ray tracing, it really doesn't help your AI video generation at all.
Section 3. The buy versus rent twist. Cloud economics. Okay, so now that we understand we're hunting for VRAM and memory bandwidth, not just raw gaming speed, we need a reality check. Let's look at the economics. because this is where we're going to fundamentally change how you think about getting your hands on this hardware.
If we take a look at the normalized data here, using the consumer RTX 5090 as our 1x baseline, check out what happens when you step up to the Workstation Pro 6000. You're getting 3 times the VRAM capacity. Awesome, right? But look at the bottom row. You are only getting roughly 1.11 times the CUDA cores, and the memory bandwidth is basically identical. You're paying a massive premium for the Workstation card, but yielding only a super modest increase in raw compute power.
Let's visualize that terrifying upfront cost for a second. If the RTX 5090 is our 1x baseline for price, the Pro 6000 sits at a 6.6x multiplier. You are paying over 6.5 times more to buy it outright. If you're a solo creator, this massive upfront cost is usually where the dream of having 96 gigabytes of VRAM just kind of dies. But wait for it. Here is the plot twist.
See what happens when we look at cloud rental prices instead of retail purchase prices. Renting a 5090 on a cloud service might cost you, say, around $1 an hour. But renting that massive, crazy expensive Pro 6000, it's often just $2 to $3 an hour. Notice how that crazy rental premium just shrinks dramatically?
And that right there brings us to the ultimate aha moment of this explainer. In the cloud, you can get 3 times the VRAM capacity for only 2 times the rental cost. Cloud economics completely flips the script. Suddenly, that workstation hardware that seemed completely out of reach, it's actually highly accessible when you just rent it by the hour for your heaviest rendering tasks.
Section 4, your perfect match. Which GPU is for you? So how do we actually apply this financial framework to your day-to-day creative workflow? Let's break down a few scenarios to help you find your perfect hardware match.
Let's contrast 2 super common situations. In scenario A, you're a solo creator. You're doing prompt testing, evaluating camera motion, and generating short draft resolution clips. The whole process fits nicely within 32 gigabytes of VRAM. The clear winner here? The RTX 5090. You get fast iteration without overpaying. But now look at scenario B. You're doing high-resolution work, long generations, maybe combining conditioning models and upscalers. You are hitting memory limits hard, and your system is offloading, which absolutely kills your time. Here, the winner is renting an RTX Pro 6000. Paying that 2x cloud rental premium to get 96 gigs of VRAM is literally going to save your project from grinding to a complete halt.
Now what about the freight train? Scenario C is when the B200 actually makes sense. Remember, a B200 might cost you almost $9 an hour to rent. That only pays off if you're serving multiple users simultaneously, processing massive batches, or operating a production inference service that can actually utilize its 8 terabytes per second of bandwidth. For a single creator, generating 1 clip at a time, the B200's massive capabilities will just sit there idle, and you'll literally just be throwing money away.
Finally, we've got scenario D, the hybrid creator. Maybe you aren't just doing AI. Maybe you need a real-time viewport in Unreal Engine. You're baking lighting, you need hardware video encoding for DaVinci Resolve, and most importantly, you need to actually plug a monitor into it. A cloud GPU doesn't give you a physical display output for your desk. If you're doing this kind of hybrid work, purchasing a physical RTX 5090 or a Pro 6000 if your business demands that local VRAM is absolutely for sure your best bet. Which brings us to the absolute most important question you need to ask yourself. Stop looking at specification sheets and asking, which one is fastest? The question you must ask is, which hardware limitation are you actually paying to remove? Are you paying for all-around graphics value? Are you paying to remove memory constraints with more VRAM? Or are you paying for data center scale bandwidth? Diagnose your bottleneck first, and I promise you, the hardware choice becomes incredibly obvious. And I want to leave you with this final thought, straight from our source material today. For AI video production, cost per usable result matters more than the number printed on a specification sheet. Don't let those upfront price tags terrify you, and please don't get distracted by gaming benchmarks. Figure out your workflow, leverage cloud rentals when that VRAM gets tight, and optimize for your own cost per usable result. So before you click buy on your next graphics card, you have to ask yourself, are you accidentally buying a sports car to do a freight train's job? Thanks so much for joining me for this explainer, and we'll catch you next time.